Oh, sorry, I was supposed to wait for the video to start.
Didn't I ask, does everybody have one? Okay. Derivatives of exponential and logarithmic functions. So the derivative of y equals e to the x and y equals ln x. What is dy by dx if y equals e to the x? Let's graph it and find out. Set the window on your calculator. Okay. Set the window.
Okay. Are you ready?
Window calculator. Turn on. I can turn on. Y equals.
E is.
All right. Hang on. I'm just going to close this calculator and reopen it. Specific value. Okay. So here we're going to put in x equals x, which is just going to graph the derivative. Now, if you have a grayscale calculator, you'd make this line thicker so you can see, but here we've got blue and red. Oh, and we were supposed to set the window. Dang. All right, we'll reset the window in a sec. All right, so there's the blue, and then let's look for the red. Here's the red. Right now it's... okay, we don't even need to change the window, I guess, to see this. Oh, that's interesting. So what's happened?
Why doesn't it make a purple line?
Because it just overwrites. It doesn't blend.
It should blend, though. That's what I'm saying.
Right, Tia. All right, so make this graph. We don't need to make it fixed. So what's the equation did we get for y2?
The same.
The same. So we got y is equal to e to the x. So let's prove that the derivative with respect to x of e to the x is e to the x. That's kind of cool, right? It's a function whose derivative is itself. All right, so we've got d by dx of e to the x equals the limit as h approaches 0 of e to the x plus h minus e to the x over h. What are we going to do with this? So keeping in mind, we're kind of aiming, hey, if I can get this, right, we can replace that with the 1. So what are we going to do? What's that? Factor out an e to the x from the top? Sure, why not? Okay, so what's the first term become then? E to the x times what will give us e to the x plus h? E to the h. A, e to the h. Minus what? 1 over h. Ah, well, what's this? 1. So we've got the limit as h approaches 0 of e to the x times the limit as h approaches 0 of e to the h minus 1 over h. Now, what's the limit as h approaches 0 of e to the x? Just e to the x, right? There's no h in there. So e to the x times, and what's the limit as h approaches 0 of e to the h minus 1 over h? 7. 7 divided by 7. So there you go. There's your proof, right? That's equal to e to the x. So the derivative, and this is just first principles, right? So in first principles, it's always f at x plus h minus f of x over h. Right? Cool. There's a function whose derivative is itself. Determine each of the following. I don't even know how you determine. I mean, some of them you're not really showing a lot of work. But all right, so what's the derivative of e, the derivative with respect to x of e to the 2x? It's actually a combination of kind of both. So here's what you start with. What's the derivative of e to the x? E to the x. What's the derivative of e to the 2x? You're going to start with e to the 2x. Right? So like whatever's here, that goes there. Right? So the derivative of e to the is just e to the whatever. But now we got this 2x to deal with. What do we do with it? Chain rule. Put a 2 in front. Right? So it's e to the 2x times 2. We'll put the 2 at the back, right? So we're using chain rule. So we're taking the derivative, which is just whatever the expression was, times the derivative of the inner function. The inner function in this case is whatever e is raised to the power of. So that's 2, which is 2e to the 2x. All right, so what's going to happen with e to the sine x? Yeah. Yeah. I'm going to do it in a different order. Right. So we're just going to start off with saying it's e to whatever it is, right? So it's just e to the sine x. Okay, outer function times the derivative of the inner function, which is sine x, and the derivative of that is cos x. Okay, and you can leave it in that form, right? That's fine. Or you can put the cos x first if you want. That's fine. It doesn't matter, right? If there's just two things being multiplied together, it's not really important. So, derivative of e to the x of e to the x squared plus 5x. What are we going to start by writing? E to the x squared plus 5x, right? Okay. E to the x squared plus 5x. Okay, so the first part is easy. You're just going to write down whatever you see. And now what are we going to put? 2x plus 5. Okay? And we can leave it in that form, or we can write the 2x plus 5 first, and then the e to the x squared plus 5x. You could expand it out if you wanted to. I don't see any point in doing that, right? If we had an x value to put in there, that's as easy a form to replace the x as anything else, right? X e to the root x. Okay, so now we got something else going on, right? So what do we do with x e to the root x?
Product.
It's a product, right? So we're going to use the product rule. Okay, so go ahead, use the product rule. Use it productively. You can't say that about the quotient rule. Use it quotient. So product rule is f of x times g of x is f of x times g prime of x. So I need the first function, which is x, times the derivative of the second function. Going to rewrite that here. Okay, so it's x times e to the root x times 1/2 x to the minus 1/2 plus
No, I don't.
need an eraser?
Yes, please.
No, he doesn't.
Thank you. Was that so hard, Danny?
So that's less likely to disappear. Okay, what do we want to do with this?
Yeah, over catch.
A little higher you could have taken it. Yeah. Well, I know how to throw this to you next. Okay, what are we going to do with this?
It's quotient rule.
Pull out the e to the.
Pull out the e to the root x. It's a common factor. What else?
Oh.
You got an x on top. You got an x negative 1/2 on the bottom. You're going to simplify, right? Okay. So let's maybe just start by pulling out the e to the root x. So then I've got x. Well, okay, what's that going to be? So I've got an x. So I got an x to negative 1/2. So that's x to the 1. X would be root x. It'd be x to the 1/2 over 2. Okay, so that's there. Plus 1. So e to the root x, and then let's go with a, what do we got? Root x plus 2 all over 2. I think that'll do. Right, so x times 1/2 x to the negative 1/2 is 1/2 x to the positive 1/2. We'll write that in radical form as root x. Plus, and then the second term, when you factor out the e to the root x, you just have the 1. So we've got root x over 2 plus 1. So let's give that a common denominator. So it'll be root x plus 2 all over 2. And then the e to the x multiplies. Okay, so x times 1/2 x. So you've got an x to the 1 times an x to the negative 1/2, which is x to the positive 1/2, which is the square root of x, over 2. So the e to the x, that's our common factor. We're pulling it out. we're combining these guys, it becomes 1/2 root x, or root x over 2. And this guy, that's your common factor, right? So you got the plus 1. We'll write this as 2 over 2, so we get root x plus 2 all over 2, and then the e to the x. Okay. Next one, which rule? Quotient rule. How can there possibly be enough room to write this? Okay, so you know the quotient rule, right? If you know it in terms of f and g, then I say it's g times f prime plus f times g, or sorry, minus f times g prime over g squared, right? Or g of x. So it's the bottom, or the denominator, it's the denominator, times the derivative of the numerator, which is just e to the x, right? Minus the numerator times the derivative of the denominator, which is negative e to the 2x times 2 over, can't write, I don't know why the display goes wrong. Now what? Well, we can factor out of the top, right? So let's see what we end up with. What's our common factor here?
E to the x.
E to the x, right? Okay, so let's pull out an e to the x. Okay, so I've got 1 minus e to the 2x minus, oh wait, that's not really a minus, right? It's going to be a plus. Plus 2, minus 2, plus 2.
Plus 2e.
That's already pulled out, so just 2 of these guys, right? 2e to the 2x over equals, keep going, there's still room. So we've got 1 minus 2 of these plus 1 of these. All right, so we're going to get e to the x. We're going to get 1 plus e to the 2x over 1 minus e to the 2x quantity squared. That's a good place to stop as any. Okay. Make sense? Everybody see what's going on? So we've got 1 minus one of these things, you know, call that a. 1 minus a plus 2a, which is going to be plus 1a, but it's not an a, it's an e to the 2x. So we've got 1 e to the 2x plus. And we've got that factored out. That's it. Be kind of neat. If this was a 1 minus e to the 2x, then we could, you know, cancel top and bottom. It's not, so we can't. Okay. We good? Nod your head, smile. So, what's d by dx of e to the y?
E to the y times y prime.
Perfect. E to the y prime. Now, this presumes that y is a function of x, right? So anytime we do one of these guys, right, there is this assumption that when you're doing this, that y is a function of x, okay? So it's e to the y times the derivative of y with respect to x, which is y prime. So e to the y prime.
So do we assume it's a function of x
Yes.
unless otherwise stated?
Yes.
Okay.
If we don't, and we then e to the y with e to the y with respect to x would always be a constant, right? Because whatever e to the y, you put a value for y, and you're just getting a constant, and then so that derivative would be 0.
Okay.
Right? Now, this would still work out to be 0 if, you know, because y prime would be 0. What's dy by dx if y equals ln x? Or ln, if you're a fan of the show, you can pronounce it ln. ln. Okay, so I want an ln, ln x, ln x. And, okay, this time let's go with the window. -2 to 6 by 1, and -6 0.26 by 1. Again, if you have a grayscale, which more than likely all of you, none of you have one of the color ones, because you neither have. Yeah, your parents didn't have. They didn't exist. There's a new one coming out. I think April. Yeah. There's it's. So the TI-84 colors are pretty much what you're holding in your hand. The new one is thinner, lighter. I'm not sure if there's any more pixels on the display or anything, but it's just kind of
TI Air.
Yeah, it's the TI Air. Although I like that new Mac Pro, the new 12-inch one.
Oh yeah.
Yeah, I would consider that. And usually I like a big screen. Right now I carry around a honking 17-inch MacBook Pro, which weighs like a ton compared to. So yeah, I would seriously consider. All right, so what does this say? Based on the it says do a table of values too. Make a table of values. So d by dx of ln x as a decimal. So the d by dx, right? That's going to be in y2, right? Y2 is the derivative. So if we go second function table and look at the y2s, so when x is 5, we've got 0.2, right, as a decimal. What's 0.2 as a fraction? 1 over 5. When x is 4, we've got 0.25. What's 0.25 as a fraction? 1 over 4. When x is 3, we've got 0.3 repeating. What's 0.3 repeating as a fraction? When x is 2, we've got 0.5. What's 0.5 as a fraction? When x is 1, we've got 1. What's 1 as a fraction? Well, just leave it. When x is a half, I don't have that in my table. So second table set, sure, start at -1, go by halves. Second table. So when it's a half, we've got 2. What's 2 as a fraction? Let's go 2 over 1. All right, I'm not going to go do thirds and quarters. So what do you think 1/3 will be? Yeah. And 1/4? So, well, it sure kind of looks it, doesn't it? Based on the table of values above, it appears that the derivative of ln x is 1 over x. Prove that the derivative of ln x is 1 over x. That's kind of a neat thing. So we've got this derivative of e to the x is e to the x. Like, really? It's its own derivative. And then we've got the derivative of ln x is just 1 over x. All right?
Okay.
Prove it. All right, what do they say? Let y equal ln x. Wow, it's like, didn't leave a lot of room there. Change to exponential form. So, change y equals ln x to exponential form. What are you going to write? What's the base? E. What's the exponent? Because I need to know the exponent. What's the exponent? Yeah, because we need, you mean the letter y. And what's that equal to? X, right? So we're changing from logarithm. Did you guys do ln in 30-1? No. Okay. But we did it in 31.
Yeah.
It's like, what's the one thing? It's like the distance formula. Have you ever done the distance formula? Distance between 2 points. Yeah, seriously. In high school math, you have yet to do the distance formula, right? We are going to hit it at some point in this course. It's just, how do you get through to the calculus and you haven't done the distance formula? It's like weird. Okay, anyway, so we changed to exponential form, and then what we're going to do is take the derivative, right? So what's the derivative of e to the y?
E to the y.
E to the y prime, right? Now, yeah, we can write it as y prime, I guess, right? What's the derivative of x? 1. So, what's e to the y equal to? Got an e to the y. But e to the y is? No, e to the y is x. So I can replace this e to the y with So then I can write x times y prime is equal to 1. What's y prime? You divide, don't, yeah, apparently. So what do we do with the x? We divide both sides by x. What do we end up with? Y prime equals x. What were we supposed to prove? That it was 1 over x, right? So y prime is 1 over x. Okay? Determine each of the following. You may need to use, when in doubt. I'd go with 42. Better shot. At least it's a nerdy reference. And besides, the first one has a 2 and a 4 in it, so plausibly 42 could come in. What is it? It's not 42. Okay, determine each of the following. You may need to use product rule, quotient rule, or chain rule. Okay, so the derivative with respect to x of the ln of x squared plus 4. Okay, what's the derivative of ln x? 1 over x. What's the derivative of ln of x squared plus 4?
1 over x.
1 over whatever's in the bracket, right? So 1 over x squared plus 4. What else do we have to do? Got to use the chain rule, right? So what's the derivative of x squared plus 4? 2x. Okay, so what do we get? 2x over x squared plus 4. Right? No simplification. You can't factor the x squared plus 4. There's no common. Right? I mean, if we can simplify, we would simplify, right? And, you know, like, if you should have simplified. So in a written response, if it was kind of obvious that you could have, like, factored something out and simplified and you didn't, then you might be looking at losing a half or something. And in a multiple choice, at some point you want to look at the answers, right? And maybe before you start, because you're just looking to say, what form is this answer in, right? Like, what am I aiming for? I'm aiming for one of these 4 things, and I'm hoping that they could at least put the correct answer down as one of them. So you're making, it's a big leap of faith at that point, right? That they actually have an answer here, but assuming that they do, right? You know what you're aiming for. All right, so what's the ln of cos x?
1 over cos x.
1 over cos x times negative sine x, which can be written as negative tan x, or negative sine x over cos x, and then negative tan x. So here, if you want to see that, we'll move that down there. So equals negative sine x over cos x, which is negative tan x, right? Okay. So if you're looking for answers and you see a negative tan x as one of the 4 choices, you say, how do I get this to be tan? Oh, okay, yeah, negative sine over cos. Oh. What's the derivative with respect to x of the ln of x to the 5th? So we're going to start, so the 5 is this outer thing, right? Like something is being raised to the 5th power. So chain rule says you're going to do 5 times whatever, ln x in this case to the 4th. So it's 5 times ln of x in brackets to the 4th. Okay. That could be written, or this could have been written as ln to the 5th of x. You know how you write sine squared x? You could write ln 5x, right, which means the ln of x to the 5th, just like sine squared x means really the sine of x squared. Okay. So had you seen ln to the 5th x, so you might have seen this, right? Maybe it started like this, d by dx. Okay. Then you should say, okay, that really means this, which gives me this, and then what else do I need? Derivative of the inside, which is 1 over x. So I'm going to write that there, and then we'll just put it all together. So it's 5 ln. Okay, I'm not going to write that. So it's 5 ln of x to the 4th over x, or okay, and do not get tempted to cancel these. Right. First of all, it would make absolutely no sense if you did, because you'd be sitting there looking at a long one and say, how could that possibly be? It can't. Okay, that's just alternate form of writing that, right? The ln of x to the fourth is ln to the fourth of x. Okay, the ln of 1 over 1 minus x. So what's that?
1 minus x.
Yeah. Right? Like it's 1 over 1 minus x, right? So you could just look at it and say, all right, if I'm doing the ln of a fraction, I just take the reciprocal of it, right? Like that would make life a little bit easier. Do you want me to write down 1 over 1 minus x?
No.
No, yeah, neither do I. Although on my key, that's exactly what I wrote. So it's just 1 minus x. Okay, now what? Times, what do we got to deal with now? 1 over 1 minus x, right? So now we got a quotient rule.
Oh,
Quotient rule, right? Yeah, oh, okay.
no.
Dang, so it's 1 minus x times the derivative of the top, which is 0, minus 1 times the derivative of 1 minus x, which is negative 1, all over 1 minus x, quantity squared. Okay, so that's 0. That's plus 1. That's the same as that. So that takes that. And what do we got? 1 times 0 plus 1. I know, eh? Like, how did that happen? And now, the derivative with the wristband battery is low. Yeah.
No.
Too many batteries.
Not enough batteries.
Well, one problem is this thing charges inductively, and that takes a lot longer than just plugging it straight into power.
Well, but still, if you had more batteries, then you would be fine. So there aren't too much. There's not enough.
Well, this one just uses a CR 2032 every 6 months, so.
Well, yeah, but I'm just saying, if you had infinite batteries, your batteries would never run out.
Have you seen the new, like, by the time you guys are ready to buy electric cars, which you won't need because the price of oil will be so low that, you know, it's just like, why would we want to? But they've come up with these, like, really fast charging batteries, and there's this graphene stuff, and all kinds of neat stuff out there. You'll get to study.
But electric cars are garbage.
Whoa.
You ever been in a Tesla? I don't think those are garbage. Anyways.
No, I don't know anything about cars.
Yeah. Elon Musk. Come on. All right. So the derivative d by dx of the ln of 4x plus 2 cubed. This is not ln cubed of 4x plus 2. This is the ln of something which is being cubed. So where do we start with?
1 over that thing.
1 over that thingy, right? So it's 1 over whatever's here, right? So that's equal to 1 over 4x plus 2 cubed. 4x plus 2 cubed times what? The derivative of the inside, which is 4x plus 2 cubed.
3 times 4 squared.
So 3 times 4x plus 2 squared times 4, right? Because we need the derivative of the integral. Okay, let's throw that over 1 so that we've got a clear numerator and denominator, right? Chain rule is kind of neat because if you don't think about it, you just sort of keep going until you run out of stuff to do, right? That's like, when do I stop doing chain rule? When you run out of stuff to do. So here, I ran out of stuff to do, right? I did the derivative of the 3 from 4x plus 2, got that squared. Oh wait, I still got this. Okay, I've done that. That's it, I'm done. Okay, what do we got? Well, that is going to take that out. And we've got 12 over 4x plus 2. 6.
Give him a goddamn second.
Yeah.
Give him some
Try,
credit.
yeah, no, that's good. I mean, it's like, keep going, right? Like, please simplify your fractions down. Don't leave something that's like, that's equal to 15 over 5. Yeah, and most of us would say that that's really equal to 3. So why don't you just go to the 3?
But he's not wrong.
No, that's true.
It's not technically right either.
Yeah.
He is technically right.
Part B, derivatives of y equals b to the x. So what do we do with like exponential functions, right? 2 to the x, 10 to the x, whatever. And y equals log base b of x. So we've done ln, or log. What do we do with log base b? What is dy by dx if y equals b to the x? Let's graph it and find out. Let's get out of the table. So we are going to set our window. This time we'll do the window. -5 to 5 by 1. -5 to 5 by 1. What? -5 to 5. And -2 to 5. -2 by 1. We're going to do y equals as what? We can't do b to the x, so we're going to do 2 to the x. 2 to the x. No. All right, we're going to clear this, which I should have done in the first place. 2 to the power of x. Graph. All right, so there's 2 to the x, right? Very nice little exponential function. We all know what that looks like. And here's, in red.
Why is the second one so slow?
Yeah, because it's actually calculating the derivative and having to,
Still, hanging over. It's slapping.
This is, yours is probably slower.
Well, yeah, exactly.
Yeah.
And I'm very upset with that.
Well, there's the new TI 84 Air. I don't know, I saw it at convention, I thought, that's kind of cool. It's like, when's it coming out? Like, April, okay, well, so it's for next year's people, right?
How is that one?
All right, so what does this say? The graph produced by y2 appears to be a blank stretch of the graph. What might we put in the blank?
Small.
Small, yeah, or there's other words that could be used. A vertical stretch. Yeah, okay, appears to be vertically stretched. Determine the stretch factor and compare it to ln of 2. Are they the same? All right, so this is at 1, so the stretch factor is going to be whatever that intercept is, right?
Sure.
Second calc. Oh, wait a sec. Clear. What do I want to be on? And no, you don't use trace.
You could do the table.
You're right. I could do the table. Why not? Okay, well, let's put in a 0 and see. But that, okay, there's y1, so we can just pop down to y2. 0.69314. Compare this to ln2. .69. Are they the same? What do you think would go in this blank? No, it's something different. Yeah, okay, I don't know. Let's say yes. Therefore, d by dx of 2 to the x is equal to what? Well, not just ln2. It's equal to ln2 of 2 to the x, right? It's a vertical stretch, so it's like the a value in an equation, right? Y equals a times. And in general, d by dx of b to the x must be
ln b times b to the x.
ln b times b to the x.
Where b is greater than 0.
Where b is greater than 0, right? Yeah, you have to be able to, it needs something of which you can take the natural log, which has to be. Prove that d by dx of b to the x is. Actually, there's another way to write this too, right? It could be 2 to the x times ln2, which is actually the way we're going to write it, or b to the x times ln b. Because that way you're taking the derivative and you say it's something to the x, and I'm just going to write down whatever that term was and then multiply by the ln of the base. Okay, so that's kind of, this is the order we want to look at, right? So it's b to the x, so you say derivative of, and I've got an exponential, then it's just whatever it is, the exponential, b to the x, times ln b. So, let y equal b to the x. Take the natural log of both sides. What's that going to give me? ln y equals ln b to the x. So what might we do with ln b to the x? So what's the magic thing you do with logs to solve for an unknown exponent? You move the x to the front, right? Using the power rule or law. Is it a law or is it a rule? So the ln of y is equal to x ln b, right? Like, why would you take log both sides? Way I could take a power and just, move it out front. Okay, so how's that help? Well, so what's... It doesn't. What do we do? What do we do?
Divide out the lawn.
You can't divide out a lawn. That'd
Not
be like
with that
dividing out a
attitude.
square root. Okay, where are we? What's y equal to? What's y equal to?
Oh, yay.
Ah.
Okay, so here's what we're going to do. I was like, why is the leap here? So y is equal to e to the power of x ln b. And dy by dx, so I've solved for y here. So dy by dx is equal to e to the x ln b times ln b. And e to the x ln b is b to the x. You have to buy this line here.
Oh, I got it. Well, because that's the same as like e to the power of x, or e to the power of ln b to the power of x, and then e to the power of ln b is the same as just b.
Oh,
Yeah, it's like
Yeah.
2 log base 2 of 5 is 5.
Yeah.
Or 2 to the power of 5.
The-
Oh, okay.
That's one of those log.
Shitty for you then.
It's one of those properties of logs that you looked at when you studied logs in 30, right? It's the what power do you raise e to get? So if you take e and raise it to the power of this, what do you end up with? So e to the ln b is b,
Yeah,
right? So we end up with b to the x.
that's what I was trying to illustrate.
Yeah, so that. Okay, then you take the derivative with respect to x at both sides, and e to the x ln b is just b to the x times ln b. All right. There's your proof. Determine each of the following. Okay, so what do we got? E to the 3x squared, or sorry, d by dx of 3x squared. So what do we start with?
2 times 3 to the power of x, and then 2.
So we've got ln of b to the x, it's equal to b to the x ln b, right? So we've got the ln of 3 to the x squared, so it's whatever's in the brackets, right? 3x squared. Sorry, you're right. 3 to the power of x squared. Times the ln of 3 times 2 to the x. Okay, times the ln of the base. Okay, then times the derivative of the inner function, which is x squared. So then times 2x. So you're basically just repeating whatever, right? I've got an exponential function inside the bracket, so I just repeat that. Then I multiply by the ln of the base. The base in this case is 3. Then, since it's an x squared, I'm using chain rule to multiply by the derivative of the x squared, which is 2x. So we end up with 3 to the x squared times 2 What's 2 times ln 3? take the power, put it back. So it'll be the ln of 3 squared, which is 9. So 2 ln 3 is the ln of 9, and then the x. Or x ln 9, I suppose. I don't know, like 3. So when you've got an exponential function, right? You're doing the derivative exponential function, you just repeat the exponential function, right? And then times the ln of the base, and then if there's something else going on, which in this case it's x squared. Okay, so d by dx of 2 cos x. We're going to repeat the 2 cos x, right? 2 cos x times the ln of the base. What's the base? 2. 2 times ln 2. Don't need a bracket there. Times ln 2. Times, what's the inner function?
Sine of x.
Yeah, so it's going to be negative sine of x. All right, so what have we got? Let's put the negative up front. We've got negative 2. That's 2 to the cos x, sorry, bad writing. 2 to the power of cos x. Right. I wrote 2 cos x, that was wrong. 2 to the power of cos x, so we've got the negative, then the 2 to the power of cos x, then the ln 2, and then the minus, then the sine x. Okay, so negative, coming from the negative sine x, bring it out front, 2 to the cos x, ln 2, and then sine x. Oh, I never did the next one. Okay, so the next one, what do we do?
Is that 5 to the power of x?
Yeah, so we're going to start off with 5 to the power of x over 1 minus x, right? Then what?
Times ln 5.
Times ln 5. Okay, so we start with the exponential function, whatever it was.
Yeah.
Then we multiply it by the ln of the base, which is 5. And then we had to use the quotient rule and...
It's not that bad, it all cancels out at the top. Oh.
Whoops. Does it? Okay, so we've got 1 minus x times 1 minus x times negative 1 over 1 minus x squared. So 5 to the x over 1 minus x, ln 5. All right, what do we got here? Well, that's just 1 minus x plus x. So that's 1 plus... Okay, how's that? Is that right?
No, the x
No, wait.
cancel.
You're right. It's just 1.
I was.
You're right. Yeah, because that's a minus x and that's a plus x.
See, even if it's spoiled, you can take whatever you want from the ending. You'll just be wrong about it.
All right, good catch. Yeah, can't add. Simple arithmetic. But it's yeah. It's not that it's hard. It's that you make stupid arithmetic mistakes. So that.
What's 1 plus 1 7?
1 and 1/7. Okay, d by dx of 2 to the x ln x. All right, so what are we going to say about 2 to the x ln x? It's a
Product!
It's a product. So we're going to use the
Product
rule. So we're going to take 2 to the x times the derivative of ln x, which is 1 over x. Okay, let's move down here. So that's 2 to the x, right? F of x times g prime of x. Okay, so times the derivative of the second function, which is 1 over x, plus ln x, first function, times the derivative of 2 to the x, which is
2 to the x times ln 2.
2 to the x ln 2. I was going to say over, but it's not a quotient. All right, anything in common here? We've got 2 to the x in common. Okay, so let's factor 2 to the x out. Really move the. Yeah. This it's better to combine this. So let's get an x as a common denominator. So okay, if I'm going to throw this over x, then I just have to throw an x up here, right? So we got 2 to the x, then we got what? 1 plus x ln 2 over x. I'd leave it. 3 to the x over x. What's 3 to the x over x? It's a quotient, yeah. So we got to use quotient rule, right? Okay, so how's the quotient rule work? It's the denominator times the derivative of the numerator. It's going to be 3 to the x ln 3 minus the numerator times the derivative of the denominator. Any common factor there?
Yeah.
What?
1.
No.
1 is a common factor.
All right, 1 is always a common factor.
Exactly.
But it's the loneliest common factor that there ever is.
Not if you give it a buddy like 3 to the power of x.
All right, so 3 to the x times x ln 3 minus 1 over x squared, and I guess you could write x ln 3 as ln of 3 to the x. So that's a possibility, right? Just be aware of what variations of this are there and which one am I going to choose. Should it be multiple choice? Last page. Here we go. We're almost there. It's okay, and that makes tomorrow a work period, right? You do lots of exponential and logarithmic stuff. So, what is dy by dx? It also gives the people that aren't here at least an hour video to watch. What is dy by dx if y equals log base bx, where b is greater than 0 and b belongs to the reals? Let's graph it and find out. Oh, again with the graphing. It's like, seriously. Okay, so what's our window? -2 to 6. The window keeps changing.
Why didn't you just pick like
I don't know.
windows again over?
I didn't pick this, trust me.
This is all your fault.
No, I'm just following along.
Okay, for our work period tomorrow, can we go beat up whoever's responsible?
Sure, so we're going to use
Yeah.
5, which is log base. Did you know about this function when you went in to write the diploma? Right, so I want log base 2 of x. Okay. If you have the newer firmware on an 84, you can do that. Alpha, and then you press one of these guys and it does stuff, right? Okay, and we want dy by dx, and being as it's in color,
That's where it's supposed to show up.
so we're graphing log 2x, there's your basic log function, right? Q4 to Q1 increasing. And we've got this.
Wow.
So sweet.
Yeah, so remember that the derivative of ln x is equal to, what's the derivative of ln x?
I don't want to be.
1 over x. Is it on your formula sheet, by the way? Is it? I don't know. I don't have your formula sheet. The derivative of y equals 2 log base 2x should be similar since they're both logarithmic functions, just with different bases. This appears to be a blank stretch. Yeah, vertical. Determine the stretch factor and compare it to 1 over ln 2. So what do we say we're going to do to get the stretch factor? All right, what's 1 over ln 2? 1 divided by, hey, there's ln 2, second function answer. 1.44. Are they the same? I don't know. What was the first graph? The blue graph? And then that's 1.44. I'm not really seeing it, right? Like I'm seeing it. It looks reflected to me. But am I missing something here?
It's not just a reflection.
No?
It should go
It is a
down,
stretch.
son.
It's a stretch.
What's it a stretch by then? Huh? I don't know.
See, well, it says it's a stretch by 1 over ln 2.
It's 1 over 2 times ln 2.
1 over 2 times ln 2?
Yeah, it says determine it and compare it to.
Are they the same? I don't know. No. I left this blank when I was looking through it because it just didn't look so you're saying, wait, it's 1 over 2 ln 2. Are they the same? Not quite. Looks like 1 over 2 ln 2. So what? 1 divided by 2 ln 2. 0.72. Okay, so what are we saying? This is I don't know. I'm going to leave that. Therefore, so d by dx of log 2x is 1 over x ln 2. Sorry, 1 over 2 ln 2, right? And in general, d by dx of log base bx will be 1 over
d ln
x ln b. I got to play with the graphs a little bit more, but where b is greater than 0. Prove that d by dx of log base bx is equal to 1 over x ln b. Let y equal log base b of x. Change to exponential form. So what's the base?
Oh, I'm just asking about why I said x ln b. If we just said that it's 2 ln 2, shouldn't we have put x?
You're right. That should be x ln 2. Inconsistencies. Yeah, x ln 2. My bad. So this would be like 1 over x ln 2. Looks like, I don't even know how you'd figure that out. Right? How did you figure that out? You said it was graphed. Oh.
We demand answers.
I graphed it. You're smarter than me. Okay, so we've got b to the y is equal to x. Let's take the derivative of both sides. Okay, so d by dx of b to the y, d by dx is equal to d by dx of x. So what's the derivative with respect to x of b to the y? B to the y. Right, so it's an exponential, right? So it's b to the y times the ln of the base, right, times ln b. And since it's a y, we also got a y prime, right? And what's this derivative? 1. So what's y prime? 1 over. Okay, let's just write it. B to the y, ln b. What's b to the y? So instead of b to the y, I can write x. So it's x ln b. And there's the proof. to me, I'd have just straight given that and said, do this. Okay, so log base 2 of x squared minus 4. All right, so what is this? 1 over x. So in this case, the x is x squared minus 4, right? So it's 1 over x times the ln of the base, so ln 2, times the derivative of the inside function, right? So times 2x. Is it on your formula sheet? Derivative of, yeah, okay. So at least you're given it, right? It is on your formula sheet. So the derivative of log, what does it say? Log base b of x? Yeah. So they give you the derivative of log base b of x is 1 over x ln b. So it's 1 over whatever's here times the ln of the base. And seeing as whatever is here is a function, then we need to use chain rule to get the derivative of the inside function, which becomes 2x over x squared minus 4 ln 2. Next one, log base 4 of. Okay, so what do we start with? 1 over the expression times the ln of the base. Okay, remember, whatever's in the brackets, right? 1 over whatever's in the brackets times the ln of the base times the derivative of the expression that's in the brackets, the inside function, right? Which is 2x over x minus 1. Which pulls out what? The quotient rule. So it's x minus 1 times 2 minus 2x times 1 over. And so all we're left with to do is to simplify this, right? Okay, so let's just kind of flip this. So this goes up and this stays down. So we've got x minus 1 over 2x ln 4 times, all right, what's this? 2x minus 2 minus 2x. That's kind of nice. Okay, so x minus 1 takes out the square, leaving us with just an x minus 1. 2x minus 2x. So I've got a negative 2 over 2x ln 4 times x minus 1, and the 2's. So we've got negative 1. Could leave some space. Negative 1 over x ln 4 x minus 1. Now you can get rid of the negative up top if you expand the bottom here, right, and get x squared ln 4 minus this, but then let's get rid of this negative, so we're just going to change the signs in the bottom. So we'll end up with a 1 up top. We'll multiply this but change the sign. So we'll do the negative term first because it's going to be positive. So it'll be x ln 4, and then the term which was positive will be negative, so minus x squared ln 4. Okay, and again, might see this, might see this. Yep.
So should we always try to make it positive on tests?
If you can, and there's time, and and I think you'll see it in the textbook. They'll do that, right?
But it's okay to leave it negative.
I think, yeah, right, because it's a step away.
Yeah.
So really, I mean, the big thing is on a multiple choice test. Like at some point, I don't even know when that point is. At some point, so before you do the question, should you just look at the answers to sort of say, this is the form I want? Or should I just kind of do the first step? It's like, okay, I know I'm going to use the product rule. All right, so let me do the first step of the product rule, and then let's see what form the answers are in so I can decide what am I aiming for, right? Like I'm going to aim for one of these guys. I think just doing them, you just have to decide for yourself at what point you want to kind of look. So in summary, if y is a function of x, Then d by dx of e to the y is e to the y prime, or d by dx of y. B to the y is b to the y ln b times y prime, or dy by dx. The ln of y is 1 over y times b. And so are these all on your formula sheet, or?
Except for e to the x.
Except for e to the x, okay. So e to the x is e to the x, right? So this you need to know. Derivative of e to the x is e to the x.
1 equals 1 isn't on the formula sheet either.
And look, it only took a little over an hour. Yeah, we don't give you the formula for the perimeter of a triangle.